Assalamualaikum and good afternoon everyone. I am Afsana Supria and my teammate Nasif Jamil. We are going to discuss about the determination of lithology and groundwater qualities through resistivity survey. And this is our presentation title, Uncovering the Secrets of the Subsurface, a resistivity survey for lithology and groundwater quality. Today we will talk about what is resistivity survey, how the resistivity survey is carried out, determination of lithology by resistivity survey, determination of groundwater quality by resistivity survey, and the limitations of resistivity survey for lithology and groundwater quality determination. At first, what is resistivity survey? This is a geophysical method that is used to investigate the electrical properties of the subsurface material. This is a technique involves measuring the resistance of the materials to the flow of electrical current. Next, how the resistivity survey is carried out. Generally, the resistivity survey is carried out by placing electrodes over the ground or into the ground, and a small electrical current is introduced through the ground. Through one pair of electrodes, and the second pair of electrodes measure the potential difference. And the arrays that are taken into account in resistivity measurements are Wiener arrays, Lamberger array, and dipole-dipole arrays. Here is a figure showing the electrode configurations of these arrays. So now, determination of lithology by resistivity survey. As you know, soils and rocks are essentially non-conductive materials, except some exotic materials like metallic cores. So the resistivity of soils and rocks are generally governed by the amount of pore fluid, the type of pore fluid, and its resistivity, along with the arrangement of the pore space. It is feasible to distinguish between different types of lithologies based on their electrical properties, and this is possible because of wide range of variations in resistivity for the different types of materials. Here we can see a diagram which is resistivity versus lithology. The sand showing the high resistivity value, whereas the thick clay showing low resistivity value. Here are some general steps to determine lithology by resistivity survey. The first step is conducting a resistivity survey, and this is done generally by placing electrodes on the ground, and we obtain the resistivity values and plotted it against the depth. By doing this, we can get a resistivity profile. The second step is identifying the resistivity patterns. From the resistivity profile we get from step 1, we can see wide variations in resistivity for different types of materials, which is used to interpret the lithological changes. The third step is comparing resistivity values with known values. The resistivity values we get from the survey can be compared with some known values of lithology. And the final step is correlating with other data. To confirm our survey and observation, we can correlate our data from some existing data like geological maps, drilling logs, etc. Here is a figure of lithological column and resistivity well logging curve of borehole. The wheel showing the low resistivity value along the mud conglomerate, and whereas the higher resistivity value showing along the sandstone, mud-bearing sandstone, and pebbly sandstone. The above figure showing the resistivity values of common rocks and soils and materials that we get from a survey area, and below that, this is a resistivity profile we get from electrical resistivity survey. And the orange color area showing the higher resistivity value, whereas the cooler color area showing the low resistivity value. The next part is determination of groundwater quality by resistivity survey, and this will be discussed by Nasif.
Assalamualaikum. Now we will discuss about determination of groundwater quality by resistivity survey. We can actually evaluate the resistivity. We can actually evaluate the quality of water in aquifers by resistivity survey and by the determination of groundwater and the subsurface earth material. There is a color chart showing resistivity versus quality color chart. Here, high resistivity value means the fresh water and low resistivity value means sea water or salt water. So there is a saying that the more conductivity of water is less purity of water. So there are some factors which actually control the conductivity of water. These are ion concentration, temperature, total dissolved solid or TDS, and pH level. Here, ion concentration, temperature, and total dissolved solid or TDS actually proportional to the conductivity of water. So this increases, like the conductivity of water also increases, and the decrease of water quality. And pH level actually indicate the fluctuation of pH level increases the conductivity of water. So optimum pH level is 6.5 to 7.5. So increasing or decreasing the pH value means the conductivity of water also increasing. So there are some general processes which we use to for a resistivity survey, and these are site selection, survey design, data collection, data processing, data interpretation, and validation. There is a figure of ERT models which shows the freshwater and brackish water zone. Here the blue color indicates the brackish water or salt water, and the green color indicates the freshwater zone. There are some limitations of for lithology and groundwater quality determination. These limitations are inadequate regulation, limited depth investigation, interference from near surface features, interpretation challenges, expensive and time consuming, and limited to electrical conductivity. Thank you so much.